Take yourself back to 1917. The Great War has been raging for 3 years, and amidst the chaos, a paper is published in Germany. This seemingly innocuous paper on the quantum theory of radiation set the groundwork that eventually led to one of modern day's most iconic inventions, the laser. I'm almost a doctor. This is how lasers work and how movies get them wrong. With a device that on its own is so amazing, is it any wonder that TV and film adopted the concept and a bit of artistic license along the way? Published by none other than Albert Einstein, the 1917 paper introduced theory that led to the eventual development of the laser. So complicated though, it took 43 years for the first light-emitting device that we would recognize as a laser to be developed by physicist Theodore Maiman. Since then, lasers have become ubiquitous throughout society, finding uses from the mundane disc readers and printers to complicated missile defense systems. One outlandish proposal was the US Cold War era Excalibur project, where they attempted to make a X-ray space laser powered by the detonation of a nuclear bomb. Yes, that's right, a nuke-powered space laser. Fortunately, or unfortunately, the idea proved to be impractical. The acronym LASER, light amplification by stimulated emission of radiation, refers to their working. Light refers to the visible part of the electromagnetic spectrum, so a laser using microwaves is actually a maser, and one using X-rays is a zaser. As for what a laser does, well, apart from blow things up in movies, it's a device that produces a monochromatic, coherent beam of light. Let's break it down. Monochromatic, mono meaning one, chroma referring to light, means one wavelength, or you can think about it as lasers having a single colour. Coherent, on the other hand, refers to the wavelengths themselves, and, as you can see in the image, is where the peaks and the troughs of all these waves line up with each other. Whilst you'd never be able to see this phenomena with your eyes, it is very useful in research and industry. It might be tempting to think that with so many different types and sizes of lasers out there, that understanding how they all operate is very difficult. Fortunately though, this is not the case. Almost all lasers can be modelled using 3 basic components: the pump, the gain media, and the laser cavity. Firstly, the pump is simply just the energy source, and it can be optical, so using light, meaning you can actually power a laser using another laser, or it can be electrical. The gain media is just the material from where we get our light, and it can be a range of different things, like a solid, such as Theodore Maiman's original ruby laser, or can be other things like a gas, such as this helium neon or He laser. The laser cavity is just a chamber that allows us to bounce our light back and forward so we can build up the intensity of our laser beam. For example, let's have a look at the He laser again. As you can see here, the cavity is actually made up of 2 mirrors, and the beam between them is much stronger than the beam outside the cavity. And this is essentially how you actually build up a laser beam. After careful selection and assembly of these components, the laser will start suddenly when power is supplied. This seemingly spontaneous start is known as ignition. Now, let's get on to criticising some movies. Whilst all of these movies are amazing, and I particularly love these laser scenes, they generally get at least one of 3 things wrong. Firstly, what the beam actually looks like. Movies seem to always severely underestimate the speed of light. Light is very fast. Very, very fast. 3 times 10 to the 8 meters per second, or fast enough to go around the world 7.5 times in just 1 second. Movies, on the other hand, seem to like showing lasers as short, travelling pulses like this. Whereas realistically, we would expect to see a continuous beam that reaches its target almost immediately like this. Next point is what a laser would actually do to its target. Simply put, with enough power, you'd just burn a clean little hole through its target, something more like a laser cutter, rather than like this, where you see massive explosions. As cool as it might seem, lasers don't cause explosions. And lastly is the laser device itself. Lasers, as you can imagine, require a lot of power, so the idea of a small handheld device capable of doing significant damage is, well, impractical, if at all possible. Take this scene from Moonraker. Amongst many other flaws in the physics of this scene, let's just look at the lasers here. As you can see, their small handheld devices may be powered by some kind of backpack. For 1979, no battery existed that was capable of supplying enough power to do this kind of damage. Now, let's look at this scene from Goldfinger, where the depiction of the laser is actually pretty accurate.
You are looking at an industrial laser, which emits an extraordinary light not to be found in nature. It can project a spot on the moon, or at closer range, cut through solid metal. I will show you.
As you can see, this laser produces a long continuous beam that reaches its target almost immediately. It is also slowly burning this target, and it's clearly a big device that is connected to main power. So the problems associated with developing a small portable power supply wouldn't be an issue. Though, this laser is a bit too far away from its target, and you would never fire, particularly at this distance, a laser at a reflective surface like gold. The beam could easily be reflected and unintentionally blind someone, which, not surprisingly, is actually the most common injury associated with lasers. And as far as I can tell, no one's ever actually been killed directly by a laser. Most deaths associated with lasers are from something peripheral like the electricals, which speaks a bit to their practicality as a weapon. Overall, whilst this is a very impractical way of trying to cut someone in half, it's actually not too bad for a depiction of a laser in a movie. So, in today's video, we had a bit of a look into the background of lasers and their basic components and how they work. Then, we had a light-hearted look at how movies depict them and the common errors that go along with it. So, if you have any ideas for topics that you want to see in future videos, let me know in the comments. And if you enjoyed today's video, don't forget the usual like and subscribe below. I'm almost a doctor, and until next time, be like a proton. Stay positive.